So the way in which the nervous and the endocrine systems regulate the internal environment is through feedback systems. A feedback system, which can also be called a feedback loop, is a cycle of events in which the status of the body is monitored, evaluated, re-monitored, and re-evaluated, and so on. Each feedback system or feedback loop includes three basic elements: a receptor, a control centre, and an effector. So a receptor is a body structure that monitors changes in a controlled condition and then sends input to the control centre. The pathway that carries the information from the receptor to the control centre is called the afferent pathway, with aff meaning toward and ferent meaning carry. An example of a receptor are the nerve endings in the skin, which detect a change in temperature. This information is then sent in the form of an action potential or an electrical signal to the control centre along that afferent pathway. The control centre, which in the case of the human body is often the brain, sets the ranges of values within which a controlled condition should be maintained. It evaluates the input it receives from receptors, remembering that a control centre can receive input from thousands and thousands of receptors, and then generates output commands when they are required. Output from the control centre travels along a efferent pathway, with F meaning away and again ferent meaning carry. In our example of a change in skin temperature, the brain acts as our control centre, receiving action potentials from the receptors, and then it generates further action potentials or electrical signals as an output which travels along our efferent pathway. The final element in our feedback system or feedback loop is the effector. An effector is a body structure that receives output from the control centre and then produces a response or effect that changes the controlled condition. So once again, we come back to that example of a drop in skin temperature. When our receptors detect this change, they send the information along the afferent pathway to our control centre. The control centre, which in this case is the brain, sends our action potentials or electrical signals as output along the efferent pathway to our effector. In this case, our effector could be our skeletal muscles. The output directs the muscles to shiver. This generates heat and raises your body temperature. So looking at that whole process again, so a change in a controlled condition occurs, and we've said that this is a drop in skin temperature. Our receptor is what detects this change. The receptor then transmits information along the afferent pathway to our control centre. The control centre integrates and evaluates this information. It decides on a response, and then it generates the output. The output is then transmitted along our efferent pathway to our effector. The effector then produces the output or the desired effect. So here the output is our skeletal muscle, which are directed to shiver, which subsequently increases body temperature, bringing the body back into a state of homeostasis. Now, the feedback system or loop that I just described is a negative feedback system, because a negative feedback system reverses a change in a controlled condition. For example, as we've just described, when our body or our skin temperature drops, a negative feedback system will work to bring it back up again. If we then get too hot, it'll work to bring it back down. Negative feedback systems are required to maintain homeostasis, and they're what produce that state of dynamic equilibrium, where controlled conditions fluctuate both above and below a set point. The other type of feedback system that exists in the human body is a positive feedback system. So a positive feedback system will strengthen or reinforce a change in one of the body's controlled conditions. The elements of a positive feedback system are the same as negative feedback, but instead of the control centre and the effector working to reduce the change that was detected by the receptor, a positive feedback system will act to increase it or to strengthen it. For this reason, a positive feedback system works temporarily against homeostasis, and it will continue increasing the change until it's interrupted by an event that is external or outside of the positive feedback system or loop. So taking a look at a few examples, and an example of a controlled condition which is regulated by negative feedback is the regulation of blood pressure, which is a force exerted by blood as it presses up against the walls of the blood vessels. So if some internal or external stimulus causes our blood pressure to rise, this could be from an increase in blood volume or from an increase in heart rate due to exercise. Baroreceptors, which are pressure-sensitive nerve cells in the walls of certain blood vessels, will detect this change. In this instance, the control centre would be the brain. The brain would interpret the incoming information, integrate that information coming in from multiple receptors, and then generate the output. And then the output is sent along the efferent pathway to the effector, which could be the heart and the blood vessels. And this output would direct heart rate to decrease and the blood vessels to dilate, which would have the effect of lowering blood pressure. So the negative feedback system has worked to reduce or reverse the original change in the controlled condition. Positive feedback systems are less common in the human body as they work against rather than alongside homeostasis. But one example is childbirth. So during childbirth, the contractions of the uterus will push the fetus into the cervix, with the cervix being that bottom part of the uterus. Stretch receptors will detect the stretching of the cervix, and in response will send electrical signals to the brain, which in turn releases the hormone oxytocin into the blood. Oxytocin causes the muscles in the walls of the uterus to contract even more forcefully, and the contractions push the fetus even further down into the uterus, stretching that cervix even more. This cycle of stretching, hormone release, and then stronger and stronger contractions will continue until the baby is born. Once the baby has been birthed, the stretching of the cervix will stop, the oxytocin is no longer released, and this positive feedback system will stop. Now, in this example, the stimulus is the stretching. The receptors are the stretch receptors in the cervix. The control centre is the brain, which releases oxytocin. And the effector is the uterus, which in response to oxytocin contracts even more forcefully.